Hello everyone, my name is Francis Masi and I'm representing my three friends. We're coming from the Polytechnic, University of Malawi. Last summer we were doing a project which we called the Novaflow. Basically a Novaflow is a supplement device that will be used on a suction machine. A suction machine, these are devices which are being used in the hospitals to suck different kind of fluids. It can be blood, it can be mucus, it can be gastric juices, many other fluids that come from patients that are used to be pumped by these suction machines. Now why do we care about suction machines? Suction machines are used in various ways in the hospitals. Like they can be used during surgery, like for example when they're doing cesarean section, whereby a patient is being operated and then the blood spills on the operation table. So the doctors or the nurses have to remove the blood from the table using the suction machine. Again, they can be used in neonatal care, whereby a baby is trying to breathe or to move out the mucus from the nose, so they can actually put in some chips into the nose to pump it out using the suction machine. Now, even though these machines are working, we've noticed some few problems with the already existing way of handling this machine. Because currently now the nurses have to manually monitor the device that they're using it to see if the bottles are being filled with the fluid. Now, at times the nurses can forget to be looking at the bottles, and then in the end the fluid can overflow and then damage the motor of the suction pump, which in the end comes into a bad result. Now, we saw that there's a need for us to develop a device which can be used as a supplement to this device so that you can be able to stop suctioning automatically when the fluid has filled the bottle. Now, as I've already said, the existing way is whereby the nurses have to manually monitor the bottles, and when they're full, they manually have to turn off the machine. But this device we're trying to build now is like it will actually automatically shut off the device after the bottles are full. Now, imagine in a scenario whereby you're a nurse and you're at a hospital such as Queen's, whereby it's such a busy area, many patients moving around, guardians and everyone, and you're asked to work on a patient, and then you're required to use a suction machine. Probably each and every one of us would actually want to get a certain alarm to be notified that the bottles are full. Otherwise, you'd actually have to ask a nurse to come and be monitoring on the machine as you're working on the patient. But now we have free nurses in the hospitals just for their ward, a ward of 50 patients, which is not fair. So with this device, it will save us from employing another nurse to be monitoring the machine. Again, we made it to be easy to use so that people can be able to set up this device in a short time. Our first prototype was using infrared light which goes into a sensor, and when the bottles are full, it will actually trigger it will send a signal into a controller, which the controller will switch off the power to the suction pump. Now this is the Novaflow, as you can see. It's a small device. In this black box we have the controller, and we also have the main circuit of the device. And here is the socket on which the suction pump will be plugged onto. And here is the belt that we're talking about. So in this belt we have these two small black boxes, and in one box we have the transmitter, and another we have a sensor. So this belt will be wrapped on the bottle, on the collection jar of the suction pump, and then when the bottle is full, these two will detect that kind of level, and then will actually trigger a certain signal to the controller to switch off the suction pump. We did two kinds of tests. We did a lab test and we did testing at Queen's now. So let me shed more light on the lab test. We use the lamp as a suction machine. So we have plugged this lamp onto this device on the socket here, as you can see. Now the socket is off at the moment. Now we have also plugged this device onto the main power supply, and actually the power is coming in. Now this bottle, we're using it as the collection jar on which the sucking fluids now will be going into. Now this is the belt, you see, we have wrapped it around the bottle, and now the sensor is on. That means now these sensors are aligned, as you can see this bulb lighting, the LED, the blue one. Yeah, now we're going to do the actual experiment now. So I'll ask my friend to start putting in the water. Now I'll switch on the bulb, meaning the suction is pumping now. That means after we've done all the setup, we want now the suction to start pumping. So when the bulb lights, we are pumping. Now the suction is pumping. Now the fluid is going into the bottle. So see what's going to happen now. When this light goes down, that means, as you can see now, the suction has stopped pumping. We also did another test at Queen's, now using the old suction machine, and it worked perfectly just as the light bulb experiment. So it worked probably, and we know that this is a good machine and to actually help in the hospital. So these are my two friends, and here are some of the guys at PAM. physical asset management. They're responsible for fixing broken machines at pins. And when they saw this device in their hands, they were actually impressed and they were actually happy. You can see they're smiling and they're looking so anxious to see what's happening here. So they liked it a lot and actually gave us a few recommendations about it. So of the few recommendations they gave us, these are some of them they gave us, and we were working on it. But as an client, we're working on them with my friends, trying to fix them. So we believe that this device will actually bring some impact to Malawi. Most of the devices we have, like for example the sanction machine, they're expensive machines, and usually they're donations from outside countries, and it is a priority for us to take care of them. So we believe that this device will actually help us to take care of sanction machines. The fewer we have, we'll try to use them to the maximum efficiency, so that many people can be helped through them. Thank you.